Welcome to ROAV Perfect classes. In this video, I will discuss about Banker's algorithm. And in Banker's algorithm, I will discuss about deadlock avoidance. We already discussed in previous videos about deadlock. In deadlock state, execution of multiple processes is blocked. Deadlock avoidance strategy involves to maintain a set of data, and data is used to make a decision whether to entertain any new request or not. If entertaining the new request cause the system to move in a unsafe state, then it is discarded. Now I am going to discuss about Banker's algorithm. Banker's algorithm. Banker's algorithm is a deadlock avoidance strategy. Deadlock avoidance strategy. It is called so because it is used in banking system. Banking system. Because it is used in banking system, so that's why we use its name Banker's algorithm to decide whether a loan can be granted or not. In banking system, we have to decide loan granted or not granted to particular person. So that's why its name is Banker's algorithm. There are some requirements, prerequisites, pre-requirements. Banker's algorithms requires first, whenever a new process is created, it specifies the maximum number of instances of each resource type that it exactly needs. Data structure which is used for this to implement Banker's algorithm. There are 4 types of data structure that is used. First is available. Second, maximum resources data structure. Third, allocation. And fourth is need. Available means it is a single dimensional array that specifies that number of instances of each resource type currently available. Available means currently available resources. And max means maximum number of instances of each resource type that can request. Maximum request. And third is allocation. Allocation means number of instances each resource type that has been allocated to process. process those resources. And need means number of resources, number of instance of each resource type that process requires for execution. That is need. Banker's algorithm is executed whenever any process puts forward the request for allocating the resources, and it involves some steps. First of all, you have to check whether request made by process is valid or invalid. Second, if request is invalid, then abort. Third, if request is valid, then follow next step. In next step, banker's algorithm check if the number of requested instances of each resource type is less than number of resources available. If sufficient number of instances not available, then it asks to wait longer. If sufficient number of instances available, then it follows next step. And next step is banker's algorithm makes an assumption that requested resources allocated to process. Yeah. Then next step, requested resource allocated to process then it modifies data structure accordingly and moves from one state to another state. Now banker's algorithm follows the safety algorithm. Banker's algorithm follows the safety algorithm to check whether the resulting state it has entered is in safe state or is a safe state or not safe state. If it is safe state, if safe state, then allocated requested resource to process in real, or if it is unsafe state, then it rollbacks to previous state and ask process to wait longer. Safe state means a system is said to be safe state when all the processes can be executed in the some random sequence with the available number of resources. Safety algorithm data structures. To implement safety algorithm, there are two data structures are used for safety algorithm data structure. Use two types of data structure, work and finish. Work means if number of instances of each resource type currently available resources. Finish means when process has finished its execution or not. When process finish its execution or not. Safety algorithm is executed to check whether the resultant state after allocating resources is safe or not. Then we use safety algorithm. In first step, number of instances of each resource type currently available is equal to available. All the processes are to be executed and data structure are initialized. After that, safety algorithm looks for an unfinished process whose need is less than or equal to work. So these finds an index. If such processes exist, then previous step is followed. Otherwise, next step, step number 3 is followed. Then otherwise, step number 5 is followed. In step number 3, after finding required process, safety algorithm assume that requested resources are allocated that process. Process runs and finishes its execution, and the resources allocated to gets free. The resources are then added to work and finish. Process is set as true. In step number 4, loop of step 2 and 3 will be repeated. And step number 5, if all the processes can be executed in some sequence, then system is said to be in a safe state. In other words, we can say that if finish becomes true for all processes, then system is in a safe state, otherwise not safe state. Now I am going to discuss related to Banker's algorithm some practical problems. First practical problem is given. Here we have given question is related to this Question number 1, which I am going to discuss, that is a single processor system. A single processor system has 3 resources: X, Y, Z, which shared by 3 processes, and there are 5 units of each resource type. Now consider the scenario where the column allocate denotes the number of units of each resource type allocated to each process, and column request denotes the number of units each resource type requested by a process in order to complete execution, and which of the these processes will finish last: P0, P1, P2, P1, P2. None of the above, since the system is in a deadlock. We have given this table. Allocation request X, Y, Z, X, Y, Z, P0, P1, P2, 121, 201, 221, 103, 02, 120. Now I am going to solve it. First of all, we have available resources, you can say available instances of resource type X, Y, Z, 5, 5, 5, and we have allocated 3, 4, 5, and allocated sources are 5, 4, 3, and total resources are 5, 5, allocated 5, 4, 3, and rest we have available only Y and Z. Y is 1 and Z is 2 and X is 0. 0, 1, 2, these are the available resources. Now in step 1 you will be find 0, 1, 2 is the available resources, and according to question it said there are 5 units of each resource type. Consider following scenario where the column allocate denotes number of units of each resource type allocated each process. The column request denotes the number of units of each resource type requested by process in order to complete execution. Which of these processes will finish last? We have to find who will finish last. Now you can see here you are requesting total 2 3 5 3 2 3 5. First of all, you can see here with the instance available currently only requirement of process P1. Requirement of process P1 is 012 and its allocated resources are 201. When we add it 213, now we have available 213 sources. 213. In step 2, with the instance available currently only requirement of process 0 can be satisfied because in this we have given 103 request. Now you can add 213 103, that is in 213 you can add 1 2, available is 121, that is 314334. You can give them 334. And last you can see last process P2, that is allocation is 221. You can fulfill at the last requirement, that is P2. Then answer will be P2 is the last process who will be fulfill his request at the end. You can say there exists a safe sequence P1. First of all P1, then P0, then P2. If we satisfy first of all P1, then P0, then P2, then there is no create deadlock, and that will be the safe state. This is the safe state. You can see another example which is related to Banker's algorithm. In this question we have given allocation and max. X, Y, Z. X, Y, Z. P0, P1, P2. 0, 0, 1, 3, 2, 0, 2, 1, 1. 8, 4, 3, 6, 2, 0, 3, 3, 3. This is given allocation and maximum sources. In this question, an operating system uses the Banker's algorithm for deadlock avoidance when managing allocation of three resources X, Y, Z. Three processes are P0, P1, P2, and the table given below presents the current system state. This table shows the current system state. Here allocation matrix shows the current number of resources of each type allocated to each process. The maximum matrix shows the maximum number of resources of each type of required by each process during its execution. And there are 3 units of type X, 2 units of type Y, and 2 units of type Z. Still available. The system is currently in safe state. Consider the following independent request for additional request resources in the current state. Request 1, P0 requests 0 unit of X and 0 unit of Y and 2 units of Z. In request 2, P1 request 2 units of X, P1 request 0 units of Y, P1 request 0 units of Z. Which of the following is true? Request 1 can be permitted, request 2, only request 2 can be permitted, third request 1, request 2 can be permitted, or fourth is neither request 1 nor request 2 can be permitted. For solving this question, first of all, we have to find out what is available. Available resources. We have available resources is 3 unit of X, 2 units of Y, Z, and 2 units of Z. 3, 2, 2 is given. Now find out need. Need can be find out max minus allocation. This formula will be used for finding need. You can find it like this: 8 minus 0, 8 minus 0, 8, 4 minus 0, 4, 3 minus 1, 2, 6 minus 3, 3, 2 minus 2, 0, 0 minus 0, 0, 3 minus 2, 1, 3 minus 1, 2, 3 minus 1, 2. These are the need. Currently system is in safe state. Now check request 1. Request 1 is said they request 0 units of X, 0 units of Y, and 2 units of Z. That means 0, 0, 2. They request 0, 0, 2. Need of P0 is 0, 0, 2, and we have available 3, 2, 2. You can satisfy request 1? Yes. And in second case, you can satisfy it by this method. You have given 3, 2, 2 available sources. Out of these 0, 2, 2, when you subtract 3, 2, 2 minus 0, 0, 2, you will find 3, 2, 0. Now it follows safety algorithm to check whether this resulting state is safe state or not. If it is safe state, then request 1 can be permitted, otherwise not. First of all, you can check it when we, here you can fulfill whose need. You can fulfill whose need of 320 process P1. First of all, you fulfill this. When you fulfill its need, after fulfilling its need 320 plus, you will get 640. And 640, you can say it is not possible to entertain any process. The system has entered the deadlock state, which is an unsafe state, because request 1 will not be permitted. because with the instances available currently, only the requirement of process P1 can be satisfied. P1 is allocated requested resources. It completes the execution and free up these instances resources held it, and now available resources are 640, and you cannot satisfy you cannot satisfy another needs. Now check whether request 2 can be entertained. Request, you can see P0's need is 842, and it cannot be satisfied by 640, so that's why request 1 is not satisfied, and now request 2 is given 200, and available resources are 322, and we find 522 available resources. Total resources are available 322, need is 200. When we subtract it, then we get 122. Now it follows safety algorithm to check whether this resulting state is safe state or not. If it is safe state, then request 2 can be permitted, otherwise not. With the instances available currently, only requirement of process P1, that will be P1 can only the requirement of process P1 can be satisfied. So process P1 is allocated requested resources. It completes its execution and then free up the instances of resources held by it. 122 plus that is given because here now these are changes 520 and this is 100. Now you can see 520 cannot be, you can see 122 plus 520, that is 642. With the instances available currently, only requirement of process 2 can be, process 2 is allocated requested resources. It completes its execution, then free up instances of resources held by it. Now 642 plus 211 of process 2, 853 we have available. With the instances available currently, requirement of process P0. Now you can see we have given 853. You can fulfill requirement of process 0, that is given 853 plus and 85 allocation 001, total 854. There exists a safe sequence P1, P2, P0 in which all processes can be executed. So system is in safe state, request 2 can be permitted. I will repeat all these concepts again in next page. Again repeat it. First of all, we have given this statement. Allocation max, then we have to find need, available. X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z. 001 320 211 184 620 333. After subtracting, we have, sorry, here 843. Not moving, has some problem. 843 842 max minus allocation 300 122 and available is 322 and request 1 is given according to P0, that is given P0 002 and request 2 is given P1, that is 200. Now first of all, first request is given P0. This is P0, P1, P2. Now you can see we have available 322 resources and request is 002. When we in first step you can see available is 322 and request 002. You can see now you have available 320 and P0's need is 842. You can only satisfy need of P1 because its need is 300, or you can say 320. So here you can see it follows safety algorithm and check whether this resulting state is safe or not. When we check, then we see P1 for satisfying, we check it that only when we add P1's allocation, that is 320, total is 640. Now this is available resources and this available resources cannot be satisfy the need of P0. So that's why request 1 cannot be permitted. And according to request 2, in request 2, available resources 322 and request is 200 and now available resources are 122. In 122, first of all, you can P1's request, that is 200. 200 means here we add it 200, it will be now 520 and here it will be 100 need. Now you can see, you can check request 2 can be permitted or not. First of all, I will check here. First, I will check P1. P1 allocation is given 520 and we have available 122. Total availability total request will be 51642. 642. This is total available resources 642 and process 2 that is given. We have 211. You can satisfy its need because its need is 122. You can satisfy. After satisfying its need, resources will be free, that is 211 and first resource is 642. Now total resources available 853. Now you can see need of process P0, that is 842 and available resources 853. You can see available resources are more than need resources. Then you can see you can say that this state is safe state, but processing will be done first P1, then P2, then P0. In this case, system will be safe. There is no deadlock, and this is a banker's algorithm. Thank you for watching my video. If you like my video, please like and share my channel with your friends so that they can take benefits from these free videos, and click on like button and click on bell icon so that you can get next videos notifications. Thank you.